So hello guys, my name is Adya Ram Pandey and my registration number is 23BC16. So in this video, I'm to be talking about finite automata, its application, and specifically, I'm going to talk about application of finite automata in Predictability. So let's get started. So first of all, let's talk what is finite automata. Finite automata basically is an abstract machine which is used to recognize patterns, which is given in input sequences. So finite automata basically recognize patterns which are given as an input, and finite automata is used for forming basic for understanding regular languages in computer. So finite automata is basically used to understand regular languages. And finite automata consists of states, transition, input symbol, and processing each symbol step by step. If machine ends accepting state after processing input, it gets accepted, otherwise it gets rejected. So I'm not going to be teaching it in detail as I'm mainly gonna focus about its application. So finite automata has four types: finite state automata, push-down automata, linear bound automata, and kernel. So now let's talk about network. So networking basically is sending information from sender to receiver via packets by following certain rules which are known as protocols. We use finite automata in networking because, first of all, it builds predictability and consistency. Finite automata, as it contains states and transition, it provides step-by-step structure, making network behavior more reliable and error resistant. Then it is very efficient. Third, it has real-time security, which is used in packet filtering and IDC, which we are going to talk about later in this video. Then it is used for traffic management and error detection. Then we are going to talk about some applications of it. It First is protocol design and verification. Second is packet filtering and deep packet inspection. Third is instruction detection system or ideas. Fourth is draft shaping or quality of service. Fifth is data compression and error device. Or sixth is routing algorithm. So now let's see all of this application in details. First application is protocol design and verification of protocol network. So first thing protocols is set of rules which determines how data is transmitted, received, and acknowledged. And protocol basically handle everything in the connection. It set up connection, it manage errors, it end connection, and it manage all the data integrity. So to receive protocols, finite automata are is used in such a way that in finite automata, each step of protocol is represented as state, and each action, like sending data from server to receiver, is shown as transition. Now, let me show you by taking one example. Let's take a TCP handshake, TCP three-way handshake example. So it consists of four states. First is listen, in which server listens for connection request, which is given by client. Then second is SYN set, means client sends some packet which is moved to SYN, which is then moved to SYN send state. Then SYN receive. Then server receives that packet sent by client and then responds in SYN ACK, which means acknowledgement packet. So basically, so client sends some packet to server, and when server gets that packet, server sends an acknowledgement message to client. And when connection is established and both exchange of packet is done, then both enter established state in which now data can be easily exchanged. Okay. So in this, we can use finite automated surging with it. We can make four states. First state is listen. Second is S1 state. Third is S1 receipt, and fourth is established. And we can basically send it using transition, and we can show transition with in them in which we can show packets moving from S1 server to receiver. So let's talk about its benefit. The benefits of this thing is modeling these steps as finite automata ensures each device follows handshake as sequence correct. So in it, we have to strictly follow this step only. First, we have to listen. We can't just first receive packet and then listen. So we can achieve this thing by finite automata. And then if any sequence is not followed, Like here I have written that preventing potentially harmful or misguided consistent and sequence that break connection that break this thing can be easily achieved by finite automata. So let's move to second application, which is packet filtering and deep packet inspection. Packet filtering, first let's talk about packet filtering. Packet filtering means to see IP address, IP header, which consists of source and destination's IP address, port number, and protocol type, and see if it's fit by preset rules. There are some preset rules and see, and packet filtering basically sees packet header and verify that it sees preset rules or not. Packet filtering is typically the first line of defense in network security. So finite automata can help packet data matching against predefined rules. Each state in finite automata could represent a specific filter criteria, for example, source IP address or destination IP address or port number or protocol type, and each transition between state represent matches for those criteria. So we can and represent transition as matching between these criteria, and the automation examines incoming packet transition those states if packet data matches the rule and ultimately decide whether to allow or block the packet. So now let's talk about deep packet inspection. In deep packet inspection, we not only see the packet header, but we inspect packet payloads or packet data in addition to headers. This allows inspection to specific content. So in packet filtering, where we are just seeing that if packet header, this consists of something like source IP address or destination IP address, as verifies or matches preset rules or not. In deep packet inspection, we see entire packet payloads or entire packet data and see if it follows preset rules or not. Or anyway, it DPI is crucial for network security. In DPI, finite automata processes packet creation, checking for specific byte patterns or sequences. For example, if certain payload patterns might match unknown, malware signature, causing DPI to drop packet and raise an alert. So, if we have take example like some packet get an unknown signature or unknown antivirus, unknown virus, so DPI system brought the packet tracer and it dropped alert immediately. For example, let's see virus signature detection. A virus might have specified byte pattern that lives in a payload. Or finite automata in this case can represent patterns and states matching it against incoming packets. If finite automata sees the final states in pattern, it signals a match blockchain packet to prevent an infection. Now let's talk about ideas or intrusion detection system. So ideas is an ideas monitors traffic for unusual or unauthorized access patterns, which may indicate in miscellaneous activities. Ideas often operates on preset attack patterns or signature. Ideas is basically an monitoring network traffic signal for usual or unauthorized access patterns. So it basically monitors unauthorized access patterns, and if it sees any malicious or suspicious activity, it can raise any alert. So let's get to this finite automata in ideas help ideas to recognize suspicious patterns like scans or attempts to exploit known vulnerabilities. Each step is an attack pattern represent a state in finite automata, allowing ideas to match patterns step by step. For example, a brute force login attempts multiple failed login. In this case, as ideas can track it using finite automata after detecting several failed login attempts. Finite automata transitions to state representing a possible brute force attack triggering an alert. So let's see some of the examples like SQL injection attack. SQL injection attack basically involves inserting malicious SQL code or into query field to manipulate data. In this case, if SQL injection involves some malicious SQL code, it may not match the pattern of bits. So A finite automata in this case can drop an alert with the help of IDS or intrusion detection system. So now see traffic shaping and quality of service. Traffic shaping is used to priority limit traffic type or to optimize bandwidth usage. So at the same time, for example, if you are using two or more than two data type, for example, in this laptop, if I am just recording and downloading a videos. So right now, to control the traffic and to choose bandwidth users efficiently, we have to make a priority. So in this case, my example is in my example, I am doing a video call and simultaneously I am downloading a file. So here priority of my priority is showing video call first, and then my priority is downloading the file because downloading can wait but video call can't. So here video call is an higher video call is on higher priority and downloading is lower priority. So with the help of finite automata, each type of traffic can be represented as state and finite automata transition guide decision on how much bandwidth each type can be based on current decision. Now let's talk about quality of service. Quality of service has prioritized high demand application like voice or video or non-urgent traffic like email or file transfer. Allow system to manage these priorities dynamically. If video traffic starts, finite automata can enter a high priority states for video, ensuring low latency and high band allocation. Stream. Let's take another example of streaming video. A finite automata could monitor easily in network load and quality needs for a video stream. If bandwidth decreases, finite automata might switch to a lower quality video stream, preventing buffering. And so now let's see fifth example, which is data compression and error detection. Data compression techniques like Huffman coding and run length encoding, which is also known as RLE, are often used to reduce data size. These methods allow efficient transmission by encoding frequent patterns with shorter codes, finite automata in compression in Hoffman coding. Each symbol has binary code based on frequency. With shorter code and more frequent symbols, finite automata decodes Hoffman code by matching each bit in encoded message to state in automaton. Now let's talk about error detection with its cyclic redundancy check or CRC. This involves appending a check sequence to end of message. FA validate received data by recalculating the CRC and comparing it to the transmitted one. Now let's take an example. Simple. Uh, let's say an example that RLE compresses a repeating character. For example, in this case, I've taken A, which becomes Y. Here, finite automata tracks repetition and encode them efficiently, saving space and improving transition speeds. Now, finally, let's talk about routing algorithm. So routers are basically using algorithms to find optimal path for data packets. So routers basically he finds shortest distance from one data packet to other data packet. There are two main common algorithms used for that. First is distance routing in vector, for example RIP, and second is link state routing or we say it as LSR, which has example like OSPF. Finite automata in routing helps to track each routing decision as a state with transition and representing path changes depending on updated network information. In distance vector routing, finite automata helps routers adjust path decisions with neighboring routers, update their distance table. Link state routing, finite automata handle link state advertisement from other routers to build an updated map from network. Let's take an example of distance vector routing. A router uses in distance vector routing, a router uses finite automata to represent path to each destination. If new route lower cost appears, then finite automata to these routes optimize network efficient. Now, finally, to conclude the video, let's see some of the advantages of a finite automata. First advantage is network efficiency. Finite automata provide perform matching and transition operations quickly, ideal for time packet tracing, processing, and filtering. Second advantage is predictability and reliability. Finite automata structured approach ensures predictable outcome, marking them suitable. So I hope everyone liked my video. Thank you.